To-do lists, weather apps, tutorial clones. They work perfectly because they exist in a vacuum, performing simple actions without any resistance or variance. But building these frictionless apps teaches you very little about how software survives in the wild. This creates a specific hurdle, the developer's wall. You spend months following structured guides, but the second you try to build an original idea, you find yourself completely unable to start. Tutorials provide a paved, predictable path. Real applications are messy, filled with overlapping logic, conflicting data, and constant trade-offs. A guide shows you the syntax, the vocabulary of the language. It doesn't show you how a system behaves when it's under pressure from real-world usage. Mastering the vocabulary of code without understanding the behavior of systems leaves you unable to solve actual problems. To see this in action, let's look at a common project, a medicine reminder app. On the surface, the logic is linear. When the clock hits 9 a.m., the app is supposed to trigger the notification. But if a user misses that window entirely, this linear logic breaks and hits a dead end. It gets worse if the user changes their dosage schedule midweek. Now you have new reminders overlapping with old notifications, creating conflicting nodes. If the user opens the app 4 hours late, the system tries to process the missed dose, the current schedule, and the new updates all at once. The logic shatters. Code that works perfectly in a tutorial often collapses the moment it encounters the messy edge cases of human behavior. Fixing this isn't about writing more lines of code. It's about moving away from scripts and toward designing a resilient system. This requires state tracking. Every user action or inaction feeds into a central database first. The app doesn't just fire a notification, it checks the current state of the user's history. When the system detects a missed dose, a logic gate intercepts that event and routes it into a rescheduling process instead of letting the app fail. This allows future reminders to dynamically rearrange themselves based on the data from that missed event, keeping the schedule consistent. The goal is a system that maintains its own stability, regardless of how many unpredictable variables the user introduces. You're no longer just giving the computer a list of commands. You're architecting a self-correcting environment. This ability to anticipate where a path will break is what separates someone who merely implements features from someone who can architect a solution. If you want to improve, you have to stop building projects that have clear, predetermined answers and perfect outcomes. Seek out the things that break. Build applications that force you to handle data conflicts and edge cases, because those difficult trade-offs are where you actually learn. On this channel, we focus on that transition, moving from simple ideas to complex, logical implementations. Real engineering skill is built in the mess of reality. If you're ready to start building systems instead of just clones, subscribe.